Dear students, we are starting a chapter from your 11th class chemistry, the extraction of metals. Now, introduction to the chapter, extraction of metals, starts from the occurrence of elements. How do elements occur in nature? The most important source of elements in which elements exist or occur, that is the Earth's crust. And in the Earth crust, there are very few elements which occur in free state. So there are some elements which occur in nature, in Earth crust in free state or the elemental state. There are very few of them. And these are the elements which are not highly reactive. So in the elemental state or in the free state, those elements exist in nature which have low reactivity. Like carbon. Carbon exists in nature in the form of graphite. It exists in nature in the form of a diamond. These are the two allotropic forms in which carbon exists in nature. Then there is sulfur. Sulfur also exists as sulfur in the Earth's crust, and there are many allotropic forms of sulfur. One is the rhombic sulfur, you have the monoclinic sulfur. These are the forms in which sulfur exists in the elemental state. Then there are highly precious metals. Metal like gold, Au, metal like platinum. These metals have low reactivity, very precious, you call them the noble metals. In the Earth's crust, they again exist in the elemental state. So there is a handful of elements, some non-metals and some metals, which because of their low reactivity exist in nature in the elemental state. Then the vast majority of the elements exist in combined state. That means where the element is present as compounds. In the compound state, element can exist as oxides. There are many elements, particularly the metals which exist in Earth crust in the form of oxides, like you have iron. The major source of iron is hematite ore, where iron is present as an oxide. Then some elements exist as carbonates. They exist in the form of carbonates. And some elements exist in nature in the form of sulfides. Okay? Some exist as chlorides and so on. So those elements which exist in combined state, in nature they are highly reactive metals, they are highly reactive elements, which exist in nature and the combined state. Now those natural forms in which elements exist in nature, either in free state or in combined state, those natural forms of substances, they are called as minerals. They are called minerals. Now what are minerals? Minerals are the naturally occurring substances. They are the naturally occurring substances the naturally occurring substances which are mined from the Earth's crust. Okay, in the form of rocks, they are mined from the Earth's crust, and in these minerals, these low reactivity metals are present in the elemental state, the free state, and the highly reactive elements are present in the form of combined state. They can be oxides, they can be carbonates, sulfides, and so on. But remember, children, that whether an element in the mineral is present in free state or in the combined state, the most majority form in the mineral is are impurities. Those impurities which are present in minerals, they are called unwanted impurities. So very small percentage of the concerned element is present in the mineral, whether that mineral is in the free or in the combined state. Majority of it is the impurities which are called as gangue, or the matrix. What is a gangue or what is matrix? They are the unwanted earthy impurities. They are the unwanted earthy impurities. Like the sand, the clay, which is present in mineral. They are also present in the mineral. The unwanted earthy impurities which are present in the minerals, whether in the mineral element is present in the free state or it is present in the combined state, so they are called gangue or they are called as matrix. Now, when you extract a metal from a mineral, that mineral should satisfy certain conditions. Only then that mineral is feasible for extracting element from it or extracting metal from it. So therefore, from minerals we come to a term which is called as the ore or the ores. These are some terms that you must be very clear in your mind. Then only we'll take up the major topic, which is how do you extract iron, how do you extract copper, how do you extract silver, how do you extract zinc, metal like gold, how they are extracted on commercial scale, the large scale. The third point here are the ores. Now, if you make a comparison between the ores and minerals of an element, element has many minerals, but only few of them are ores. And it is from the ores that an element is extracted on the large scale. So what are minerals? What are ores? They are the minerals from which an element, like metal, is extracted. It is extracted economically, profitably, and conveniently. So these are the criteria. The mineral from which element is extracted economically, that means the method that will be used for extracting element from it must be cost effective. Second, it must give you large yield of the metal so that the extraction becomes profitable. And conveniently with the process which is used for extracting the element from the mineral must be simple. It must be simple, then call it conveniently. Such minerals are called ores. So it is the ores from which a metal is extracted on a large scale. So if you make a comparison again between ores and minerals, all ores are minerals, but all minerals are not ores. Because all minerals do not satisfy these criteria. That means metal is not extracted profitably, economically, and conveniently. And those minerals which do not satisfy these three criteria are not used for extracting metal, while as those minerals which satisfy these criteria become the ores, and from the ores that a metal is extracted profitably. Now you must know the composition of the ores of certain metals. So I'll present here in the tabular form the ores and their composition. The ores and their composition. I'll write it for you in the tabular form. This is the metal. The name of the ores. The type of ore. And the composition of the ore. One metal, and very, very important metal, that's aluminium. You must know aluminium is the third most abundant element in the Earth's crust. It is present to the extent of 8.5% by mass. The third most abundant element. The most abundant element in the Earth's crust is oxygen, because oxygen is present in the combined state in oxides, in carbonates, in sulfates, in phosphates. And there's a huge variety of ores where oxygen is present along with the other metals. So oxygen in Earth's crust is the most abundant element. Okay, so first one is the aluminium. The principal ore of aluminium is named as bauxite ore. It's called bauxite ore. And when we'll be extracting aluminium, and we'll be using the bauxite ore, then the different procedures will be used how to extract aluminium from the bauxite ore. The type of ore is an oxide ore. Is an oxide ore. That means aluminium in this ore is present as an oxide, and the composition is aluminium is present as aluminium oxide, and then X molecules of water of crystallization. So in fact, it's a hydrated oxide ore, because in the mineral, in the ore, bauxite, along with the aluminium oxide, you have molecules of hydration. So it's a hydrated oxide ore. And this is used, this ore is used for extracting aluminium by a process like you will learn later on, like Serpex process. Serpex process will be used to extract aluminium from this oxide ore, that's bauxite ore. The second metal is the iron. Iron, it has many ores. It has many minerals, it has also many ores. The principal ores are, one is hematite ore. Hematite ore. And the type of the ore is an oxide ore. What does it mean? Iron is present as iron oxide. And iron has many oxides. One is ferrous oxide, another is ferric oxide, Third one is ferric oxide, which is a equimolar mixture of ferrous and ferric oxide. Here aluminum is present, iron is present as ferric oxide, Fe2O3. And this one will be used for extracting the different varieties of iron. You know, iron has different varieties, commercial varieties. And three principal varieties are the cast iron, and that cast iron will be extracted from this hematite ore. Then cast iron is purified and converted into more pure form of iron, which is the wrought iron. And then there's one more variety of iron which is called as steel. That steel is used for manufacture of many alloys of steel, like you have tungsten steel, you have stainless steel, you have the tool steel, which is used for making tools, and so on. So all those varieties will be extracted from this hematite ore, where iron is present as ferric oxide. Then there is one more ore, that is the limonite ore, limonite. And what is limonite ore? This is hydrated oxide ore, like bauxite, oxide ore. And iron is present as Fe2O3, that's ferric oxide, and then there are X molecules of water of crystallization. This is anhydrous, doesn't have any water of crystallization, that's hematite ore, whereas limonite ore has X molecules of water of hydration. The third one is the magnetite ore. Magnetite. These are the names of the ores. It's an oxide ore. In this oxide ore, the composition is, it is Fe3O4. And this Fe3O4 is a mixed oxide. It's a mixed oxide of ferrous oxide and ferric oxide with equal quantities. So equimolar quantities of ferrous and ferric oxide make the ore, which is called magnetite ore, with the composition Fe3O4. Then third ore is the siderite ore. These are the names of the ores of iron. Siderite ore, this is a carbonate ore. And iron is present as iron carbonate, FeCO3, iron carbonate, FeCO3. One more ore of iron is iron pyrites. Iron is present as sulfide. This is the sulfide ore. And in this sulfide ore, iron is present as iron sulfide. So all these ore are the principal ores, but the ore from which metal is extracted commercially, the iron, is the hematite ore. So in our later lectures, you will see how we'll be processing this hematite ore in order to extract the three commercial varieties of iron, which is the cast iron, the wrought iron, and the steel, which is again of great importance, and Kashmiris use it in their homes for making utensils. That's the copper metal. The third one is the copper metal with the symbol Cu. But copper has many, many uses. Industrially, it's used mainly for making certain alloys, like you have brass, then it's used for making bronze, and the principal use of copper is for making the wires, the copper wires, because copper has very, very high ductility. That means it can be drawn into thin wires. So these are the principal uses. Its main ores are, number one is copper pyrites. Copper pyrites. And by now you must have understood that pyrite is used for the sulfide ores. This is the sulfide ore. And the composition is CuFeS2. Actually, this copper pyrite ore is a mixture of copper sulfide and ferrous sulfide. Then the next ore of copper is cuprite ore. Cuprite ore. This is an oxide ore of copper. And copper is present as copper oxide, Cu2O. The principal ore out of them is the copper pyrites. So extraction of copper, again, becomes a later lecture, that copper is extracted on large scale from copper pyrites. And the fourth metal, silver. Silver has many uses. In the days of Maharaja and Rajas, it was used for making coins, so called as coinage metals along with copper. But now it has other uses. There are no more coins made up of silver. It's used for making jewelry, the ornaments. It's used for making the fillers, the cavity fillers, which is called as dental silver. Again, very important use of silver. Its principal ore are, one is silver glance, silver, horn silver. The name is horn silver, sorry. It is the horn silver. This horn silver is the chloride ore. Here, silver is present as silver chloride. The second one is the argentite ore. This is the sulfide ore, where silver is present as silver sulfide, and this is the principal ore. In addition to these combined ores, silver also occurs in the elemental state, because silver is not highly reactive metal, though it's more reactive compared to platinum and gold, and platinum and gold are present only in the elemental state, but silver, in addition to being present in the elemental state, are also present in the combined state, and out of the combined ore, the principal ore is the argentite ore, where silver is present as Ag2S. The next one is the zinc metal. Zinc again has many uses. The principal use of zinc is that it is used for galvanization of the iron objects to prevent them from rusting. So you galvanize them with zinc. A thin coat of silver is zinc is coated on the iron substances to prevent them from rusting, which we call it galvanization. Okay. Its principal ores are, one is the zincite ore. Where zinc is present as oxide. This is an oxide ore, ZnO. Another one is that is called zinc blende, Blende. This is the sulfide ore, where zinc is present as zinc sulfide. So these are some of the metals which we'll be extracting during the course of this chapter, and these are some of the principal ores from which these metals will be extracted. Now when it comes to the extraction, now the extraction of metals, it's called metallurgy. The term is now metallurgy. What is it? The metallurgy are the procedures the methods used for the extraction of metal. from their ores on commercial scale. That's called as metallurgy. The extraction of metals from their ores. Those ores can be the combined ores, like in case of iron, in case of copper, in case of zinc, or they can even be the elemental ores or the native ores, like in case of gold, platinum. Their extraction, that's called as metallurgy. Now, different metals have different ores, and different ores along with the metals have different set of properties. So therefore, for every metal, the metallurgical procedures are different, but there are some common procedures. I'll repeat, some different metals have different properties. Therefore, while extracting metals from their ore, different methods are used. The method that is used for extraction of iron from its hematite ore is not used for the extraction of copper from its ore. The same is not used for the extraction of aluminium from bauxite ore. So different metals have different properties. Therefore, different metallurgical processes are there. But there are some common procedures. Those common procedures are called metallurgical operations. Metallurgical operations. What are they? They are the common steps. They're the common steps used for the extraction of metals from their ores. The different metals, different methods are used, but there are some common steps. Those common procedures are called metallurgical operation. And how many types of metallurgical operations are there? I'll make a flow diagram of it. These are metallurgical operations. The first metallurgical operation is called the concentration of the powdered ore. It's given a name, it's called concentration. The concentration of the powdered ore. The ore is first, ore mined from the earth's crust, so it's present in the form of huge rocks, huge lumps. What they are done with the help of jaw crushers, they are crushed into powder, and then starts the metallurgical operation to extract metal from it. So the first metallurgical operation which is done on the powdered ore is called as concentration of ore. It's given, this concentration of ore is one more name. It's called ore drussing. Ore drussing. This is an alternate name. Then it's also called as ore beneficiation. It's called ore beneficiation. This is the first metallurgical operation. I'll explain this and what are the different methods that are used for the ore beneficiation or ore concentration. Then once the ore is concentrated, then from that concentrated ore, the metal is extracted, which is the extraction of metal from concentrated ore. And in the concentration of ore, there are two procedures. One of the two, either of the two is used. One of them is hydrometallurgy. 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 And in hydrometallurgy, the procedure that is used for extracting metal is the electrolysis. Electrolysis. Electrolysis is used. And this electrolysis or hydrometallurgy, this is used for extraction of light metals. Means metals which have low density, like sodium, Na, like aluminium, metals like these. Once they are ore, and you know principal ore of sodium is the common salt, which is present in seawater or is present in rock in the form of rock salt, and from that sodium chloride, sodium can be extracted with the help of a process called electrolysis. Then there is one more way of extracting metals from their ores, concentrated ore, that's called pyrometallurgy. Pyrometallurgy. Pyrometallurgy, which means heat treatment. The heat treatment. Pyro stands for heat. The heat treatment of ore. The heat treatment of ore. And there are two heat treatments which are given. One of them is called as roasting. Roasting of ore, which we will learn. And second one is, it's again heat treatment, that's called calcination of ore. Calcination. The ore is either calcined or it is roasted. This pyrometallurgy, which means heat treatment, this is used for extraction of heavy metals from their ores. The heavy metals like iron, the heavy metal like copper, these metals are extracted from their concentrate, which is first subjected to concentration, then concentrated ore is subjected to either electrolysis, that's hydrometallurgy, or it's subjected to heat treatment, that's pyrometallurgy, and for its extraction, either of these two hydrometallurgical operations are used. Either it's roasting or it's calcination of the ore. Then once the ore is metal is extracted, the last metallurgical operation, is the refining of the crude metal, refining of impure metal. The metal that is extracted has so many unwanted metallic impurities in it. Now, depending upon the purity of the metal that you require and depending upon the impurities present on it in that crude metal, different procedures are used, different methods are used. Like the methods that are used are electro-refining, electrolytic refining is one of them. This is used. When you don't require a highly pure metal, then electro-refining is used. Like copper and gold. Copper and zinc. When they are extracted from their ores, and I already told you, the principal ore of copper is the copper pyrites. When copper is extracted, that copper or zinc is extracted from zinc blende or from the zincite ore, the zinc metal obtained is impure. It is refined by using electro-refining. Same is used for zinc. Then you have which is zone refining. Another method is zone refining. Then third one is vapor phase refining. Vapor phase refining. And then there is one more, which is chromatography. Chromatography. So all these refining methods will be clear to you when we individually take up the extraction of metals like iron, copper, silver, zinc, aluminium from their principal or the respective ores. Now, therefore, I'll again repeat it. In the extraction of metals from their ores, different methods are used, but there are certain common procedures. Those common procedures or common steps are called metallurgical operations. And generally, 3 metallurgical operations are used. The first one is the ore, powdered ore is crushed and powdered. It is concentrated, also called as ore dressing or ore beneficiation. And once the ore is concentrated, it's further subjected to extraction. That extraction from the concentrated ore, there are 2 procedures. One is either hydrometallurgy is used or the heat treatment called pyrometallurgy is used. Hydrometallurgy is electrolysis used for extraction of light metals like aluminum and sodium, whereas pyrometallurgy means heating to extreme temperatures as high as 2000 degrees Celsius. Temperature is raised in furnaces like you have the reverberatory furnace and you have the blast furnace. Those 2 furnaces are generally used when metal is extracted from the ore using pyrometallurgy. And in those furnaces, the ore is subject to either roasting or calcination, or both are used in extraction of certain heavy metals. Then once the metal is extracted, it's present in the crude form, impure form, because of impurities of other unwanted metals in it. Therefore, it's to be refined, and there are different refining procedures or methods used. Which method will be used? Number 1 depends upon how much purity metal required, how much purity, is it 100% pure, or you need say 98% pure, or you need 80% pure metal. Depending upon that, and also depending upon the type of the impurities present in it, these are the metallurgical refining procedures that are used. Electrolytic refining, you have zone refining, the phase refining, vapor phase refining, and then you have the chromatography.